Hello friends, once again welcome back to my channel Science Circle. As you all know the relation of speed, distance and time from my previous video. If you have not gone through it, once you watch the video, the concept will be clear to you. Let us recap the relation by solving an easy numerical. Suppose your car is showing the distance of 54,000 in your odometer, and when you checked it, the time was 9:30 am. Now suppose Mr. X asked you what will be the distance covered and the speed of your car at 9:50 am. At that time, you just checked your odometer and the reading it was shown as 54,035. So here we can understand how to solve it. Hope everyone is ready to solve the problem. So first we will see the initial reading of the odometer was 54,000 km and the final reading was given 54,035 km. So how much distance did your car travel? You can easily get it by subtracting it, isn't it? That is 35 km traveled by your car. Now coming to the time part. Your car started at the 9:30 am. And when you watched the second time the odometer reading, it was 9:50 am on your watch. So the total time taken to move this 35 km, we will be having 20 minutes. Now how to find the speed? We know speed equals to distance traveled by time taken. That is 35 by 20. But here the unit will be kilometer per minute. Getting 1.75 kilometer per minute. Today we will be discussing about the graphical representation of motion, that is the pictorial representation of two sets of data. As we know, while drawing a graph we have to take minimum two axes, that is x and y axis, for this distance and time graph. Along the x-axis, time, and y-axis, the distance is represented. From here we can measure the speed also. So let's get started. Suppose you are taking a graph paper and mark O as the origin at the left bottom. Now draw the two coordinate axes, that is horizontal axis shows time, and you will draw an arrow showing the increment in time, and the distance is represented on y-axis, that is the vertical axis. Now observing the time and the distance covered, we will plot the points. You can have a look of the given chart of distance and time. Here distance is represented in meter and time in seconds. Here the units of time are of very small values and it represents 1 second equals to 1 centimeter, followed by the values as 1, 2, 3, 4 along the OX, and the distance along y-axis where 1 unit is equal to 10 meters. Here 1 unit means 1 centimeter. When you are representing a graph, don't forget to write how much unit you are considering in the graph, whether you are considering 1 unit as 1 centimeter or else. Now here, as we will be plotting the points and join it, we will be getting a straight line. As in the distance time graph, for motion, if it is a straight line, we can conclude that the object is moving at a constant speed for uniform motion. Same here, if we will be plotting with the points which is given in the chart in the graph paper, you will be marking the point as A, B and C, and you will be seeing there you won't get a straight line. So you will be rather getting a curved line, which indicates a non-uniform motion. We can also find the speed from the graph itself. For example, in the x-axis, suppose you have taken 2 points as T1 and T2 and draw vertical lines to meet the graph on the distance, that is on the y-axis, and mark them as S1 and S2. To find the speed, we have to find the slope. The formula of speed equals to distance by time. So we can simply write speed equals to y-axis by x-axis, which is the slope of the graph. Y-axis denotes, we know, the distance, and x-axis denotes the time. Y-axis divided by x-axis will give you the slope of a graph. The slope of a graph will help you to find the speed of any moving object. So we can write y2 minus y1 divided by x2 minus x1. That is representing the change in the time as well as the direction. So more prominently, if we write, that is s2 minus s1 divided by t2 minus t1. From here we can easily find the speed of any moving object. Now from here we can also conclude that variation of the distance travelled by any object with time can be easily identified just by seeing the graph of it, whether it is moving in a uniform motion or it is moving in a non-uniform motion, rather than seeing the table, the data, whatever is provided. Other than that, find the speed of any moving object from the incline of the graph. Same wise, we can find the velocity as well as acceleration of any object which is moving in a particular direction. The distance travelled by any object can be also found out by just getting the area of the velocity time graph. So we can find a lot of things just by observing a graph. Now you will be seeing there are 4 types of graph in front of you. Here the first one, as we have learned, we can understand that the object is moving with a constant speed or uniform motion, that is equal distances are covered in equal time. Whereas the B graph and the C, we can understand they are moving in a non-uniform motion, that is the speed changes of an object as it is plotted, that is unequal distances is covered in equal interval of time. The last graph which you can see here, it represents a moving object stops moving, then the distance travelled by it doesn't change with time. It remains same or constant. That is, the straight line is parallel to the time axis or x-axis. So we can understand just by seeing the graph whether it is moving, or if moving, which direction or what is the speed, in which speed they are moving. Hope now you are ready to draw the graphs if the distance and the time is provided to you in a tabular form, and from that you can conclude the result of it. In fact, you can find the speed also. In my next video, you will be learning about the time period of a pendulum, how to measure it, and what are the other details of time. Thank you for watching my video. Please don't forget to subscribe my channel before closing it. Hope you will like my video, and please do share my video if you like it. Thank you.